This is the third worked example for arrays. In this case, we'll be looking at initializer lists and doing a reverse traversal. Here are the sub-goal labels for evaluating array statements. Sub-goal 1, set up the array from 0 to size -1. Sub-goal 2, evaluate the data type of the statements against the array. And sub-goal 3, trace the statements, updating the array slots as you go. Remember, for any assignment statements, you can go back to your assignment sub-goals. Here's the problem that we want to solve. Evaluate these statements and determine the output, followed by a series of Java statements. Sub-goal 1, set up the array from 0 to size -1. In this case, we are given an initializer list for the array alpha. We have int --alpha is equal to open curly brace followed by a series of numbers separated by commas, close curly brace, semicolon. The system is smart enough to know that these are the values that you want to put into the array, and it will allocate the appropriate size for that array. So alpha is an array of integers, being that the values inside the curly braces are all integer values. The statement will allocate 7 slots because there are 7 literal values given in that initialization list. Below is what the array alpha would look like. Position 0 in alpha would have the value 15, position 1 would have the value 24, position 2 would have the value 7, all the way up to position 6, the largest index, which is size -1, would have the value 13. The first statement to evaluate is system.out.println alpha.length. This statement will print 7 because the length of the array is 7. Subgoal 2, evaluate the data type of the statements against the array. There is a for loop that has an index that goes from 6 to 0 by decrements of 1. Inside the loop, the value of 1 is added to the current value at the position I in the array. All of the values being assigned are valid integers and can be stored in an integer array. Subgoal 3, trace the statements, updating the slots as you go. For the first array, we begin at length -1, so if length was 7, length -1 would be 6. We continue while I is greater than or equal to 0, decrementing by 1 each time, and alpha sub I gets the value alpha sub I plus 1. So all of the values in the array are incremented by 1, starting at position 6, going down to position 1. For the second loop, it also starts at length -1, continues as long as I is greater than or equal to 0, decrementing by 1 each time, and in this case it's printing the value of alpha sub I. The values that would be printed are the values of the array in the reverse order: 14, then 1, then -3, then 7, then 8, then 25, then 16. That is the end of this worked example.